under construction right now, but once it's up and running, which shouldn't be too long, lectures like this will be linked to the website if you want to watch them again or if you missed one. So please check that out. I also want to give a pitch for the holiday parade. You know, I was thinking about 2017 because I took part in a science march in 2017, and the science club hopefully will be marching in our parade here on November 30th. But we need participants. We don't have enough. So if you would just talk to Gail Todd. Where's Gail? She's right over here after the presentation tonight. Or send an email to scienceandsisters@gmail.com expressing your interest in marching for science. You too can be in the parade. We'd love that. I want to say a big thank you to the board members of the Science Club. Dave Duran, Joyce Blevins, Gail Todd, Joe Sherry, Larry Price, David Johnson, and Don Utzinger. We all gathered to try to put on good programs like this, and it's really, really fun working with them. We also have a new program from Dina Bateman. Dina?
Yeah.
Just raise your hand. Thank you. And Dina is going to keep everything in order for us and make sure that these programs come off without a hitch. She's new to Sisters, so make her feel welcome, say hi, and she's going to be doing a great job. We also have a suggestion jar. Topics that you're interested in, please write them. They're little pieces of paper. Drop them in the jar, or if you have speakers that you're aware of that we might want to contact and see if they're interested in doing this kind of programming, let us know. It really helps. Thanks. Also, a big thanks to Peyton Myrie. Did I get it?
Yep.
All right. Peyton is our tech guy. He makes sure that technology works for us and for our speakers. Finally, but importantly, much appreciation for Angeline and the Belfry for hosting us once again, hosting us the fourth Tuesday of every month except for December. And of course, you might have noticed this is the third Tuesday, but that's an exception because Thanksgiving is next week. So one more little thing. Thanks for anybody who can stay after we're done. And if you have the time and energy to pick up a few chairs and help us put the Belfry back in order for Angeline, that would be great. It's now my great pleasure to introduce Aaron Bott. Aaron's a wolf biologist for the Oregon Department of Fish and Wildlife. He lives in Prineville with his family, and he's also a PhD candidate at Utah State University. Aaron's research focuses on wolf social behavior, predation, patterns, and developing innovative, non-lethal techniques to mitigate conflicts with livestock. Aaron began working with wolves while pursuing a master's degree with the Yellowstone Wolf Project, eventually conducting years-long research in the deepest recesses of Yellowstone. Aaron was born in the Rocky Mountains. I think that's where he developed his love for the outdoors and for the creatures that live in it. We're going to hear a little bit about that now, so let's give Aaron a big round of applause.
Wow, what a group. Boy, if I had known how many people were going to show up tonight, I would have said no. Thank you very much for that generous introduction. By way of extending that introduction, I'll just say howdy. Hi, everyone. Thanks for having me come out tonight. We're going to be talking about wolves, but specifically, we're going to be talking about wolf biology and ecology. As a wolf biologist, I have the pleasure of interacting with people all across the state of Oregon, and wolves are, big surprise, a charismatic and controversial animal. Tonight's presentation is designed to talk about the biology of the wolf. So we have meetings about wolf management. Those can be controversial, and coexistence with wolves. Those can also be challenging and engaging. But tonight, I've been directed just to talk about the biology of this animal. So I am going to break my own rule a little bit towards the end of my presentation, if I don't run out of time. And I will talk just a little bit about the recent history of wolves in the state of Oregon. But again, most of tonight's presentation is just to be informational regarding the background of what this animal is that gets so much attention globally. Yeah, I'm an informal person, so I have to state that up front. I'm probably going to wiggle a lot and walk back and forth, and if I walk away from the mic and you can't hear me, then just shout at me. And I look forward to a Q&A at the end. It was great to socialize with a lot of you before this started, because I got a better feel for what my audience is curious about. And so I might deviate a little bit from the presentation that I prepared this evening. But bear with me. It's okay if we go off of the crazy railroad tracks of tonight's presentation. My PowerPoint will survive, and I'll save it for another day. Let's dive right into it. Rudyard Kipling wrote in his book, The Jungle Book, "For the strength of the wolf is the pack, and the strength of the pack is the wolf." He wrote this about his character Mowgli, who was adopted by a wolf pack in India, and published this book in 1894, 100 years before the wolf reintroduction into the northern Rocky Mountains. Well before many seminal studies were conducted on wolf behavior and ecology. And yet, this quote, taken from this book, really truly summarizes what a quintessential wolf is all about. And tonight we're going to be talking about that. Wolves are dogs. Once you take a wolf away from its pack, they're not as interesting, in my opinion. But wolves are fascinating to many people and have captivated humanity for millennia because of their social behavior. And that's what I'm going to be focusing on tonight. That's what my research is primarily on. It's not the individual, but the group that makes this animal very incredible. And we're going to investigate together why that's fascinating to us. And we're going to look at their evolutionary history, we're going to look at their biology and their ecology, and explore some of the things that we've discovered about wolves in the last few decades. Also, since I almost forgot, a lot of these photographs are mine, and this one is not. Isn't it remarkable? My buddy Ronan Donovan is a phenomenal photographer, and I'm just a biologist, so I lean heavily upon shoulders bigger and broader than mine to generate cool PowerPoints like this. As was mentioned, I grew up in the Rocky Mountain states, where my family settled 6 generations ago in the 1840s. I lived there and loved it. I'm still very much in love with it. I moved away for the job that I'm currently in as a wolf biologist, and I still have family back there. I grew up right next to Yellowstone National Park, 5 miles from the entrance. I remember being in my grandpa's house and listening to him talk about the drama of the wolf reintroduction that was taking place in Yellowstone. And that, I think, is what first gave me an impression about wolves. It's that and probably all the paraphernalia that the gift shop started to sell after that. But I grew up in a really remarkable landscape, and like many youths, I took it for granted until I moved away, and then realized just how special of an environment I had lived in and wanted to go back and spend my life avoiding a necktie in the cubicle, and working to protect what I care so much about, which is wild places and wild spaces. And wolves, at a social level, at a human value level, definitely they summarize wildness in a way that most other species don't. I've had the opportunity to work in multiple states on every large mammalian species found on the continent, with the exception of polar bears. Spent a lot of time working with grizzly bears, but I was pulled back into wolf research. And again, I think the reason why it was so fascinating to me isn't because of the wolf, but because of the pack. So I study sociobiology, which helps us to examine how social behaviors evolve and are shaped by natural selection. And this should be fascinating to all of us, but most of us take it for granted. The reason why it should be fascinating to all of us is because we, like the wolf, are one of the only species on the planet that lives in these cooperative and communal family groups where we take care of one another. Again, we take it for granted that most other critters on the landscape live like we do. And so it's sometimes not as much as of a surprise when we talk about wolf packs and mention breeding pairs and alloparental care is a word that we use, talking about siblings and helpers helping to raise offspring. We take it for granted, and it's not a surprise for us, or it's not that sexy to us sometimes because that's how we live. But most of the animal kingdom does not live like that. 90% of mammals are solitary, and they don't live in groups. The only times they socialize is when they have to socialize, which is to reproduce. Nevertheless, living in a social group, a social environment, for cooperation's sake, for protection's sake, for foraging's sake, has been extremely advantageous to the human species. It's been a tremendous agent in our own evolutionary trajectory. Now, there are some drawbacks with living in a social group, some major drawbacks, which is why most of the animal kingdom has not elected to pursue this evolutionary trajectory. I'm not going to get into those tonight, but competition, disease transmission, hierarchies, those are some of the main reasons why you have drawbacks or costs to group living. But for us, it was very beneficial to work together, to protect one another. And it allowed us to not only evolve physically, morphologically, but it also provided the opportunity for cultural evolution and social learning transmission, so that we have exactly what we're doing tonight. We're transmitting knowledge and education from one group of people to another, and that has defined us as a species. To the extent that we have successfully dominated the entire planet. We are the kings and queens of planet Earth. For good or for ill, our footprint is large, and we are heavy-handed upon this planet. But again, it was our grouping behavior that led to this. And without wanting to get into the weeds too much, oftentimes in evolutionary biology, we refer to direct fitness, which is essentially our own potential reproductive chances of success, passing along our alleles and our genes to future generations. Sometimes that's referred to as biological fitness or Darwinian fitness. So we have that, which all reproducing animals have. They have to pass their genes on in order for them to be biologically fit. But then we also have kin selection, and we have what's called indirect fitness, which means that we have folks in our lives, our family members, which share a lot of the same genes that we have. And sometimes unconsciously, and sometimes consciously, we spend a lot of energy and effort trying to ensure, again, that our alleles, our genes, get passed on by cooperating with one another. And there's no stronger unit in the animal kingdom than the family that cooperates and works together. Again, foundational not just to our biology, but also to our culture and our sociology. And fortunately, group fitness, group socializing provides the best of both worlds. So we call this inclusive fitness, where individuals can work with related individuals in order to promote the best chances of success, if you can follow that. And that's exactly what humanity has been doing for the last at least 200,000 years, since we left the cradle of Africa and we began to expand northward into the northern hemisphere. We were beginning the dawn of our conquest of planet Earth, marching forward as a very social species. And as we left Africa, as we migrated north, we came across another animal which, like us, lives in cooperative social breeding groups that works together as a family and also has a tremendous distribution across the globe. In fact, after humans, wolves have historically had the greatest historical distribution on the planet of any terrestrial mammal. That's a lot of words, isn't it? But in a nutshell, wolves have a very large footprint as well upon the earth. Primarily restricted to the northern hemisphere, but that's still very impressive. So as humanity spread across Europe and Asia and into North America, everywhere that we went, we encountered this very successful species which was ahead of us in terms of their dispersion on the landscape. So we're going to switch gears for just a minute and now talk about wolves. That's why you're here. And we'll focus a little bit more directly on the evolutionary perspective of wolves. Wolves are today the largest living canid. However, they did not emerge as the largest canid on the landscape back in the Pliocene and Pleistocene. In fact, they were rather runtish, not quite as squirrely as a coyote, but still not the top dogs by any means. Most of us are familiar with the megafauna that lived all across the globe back during the Pleistocene, or the Ice Age. We had mammoths and mastodons, but we also had a complete, now absent guild of large carnivores, such as here in North America, the short-faced bear, in addition to our black polar and grizzly bears. We had saber-toothed cats, a wide variety of them actually, in addition to our mountain lions. We had lions, actual lions, African cheetahs, and we had a larger cousin of today's Canis lupus, which was known as the dire wolf, about 50% larger than our modern wolves today. This wonderful illustration by Mauricio Anton illustrates what I'm getting at, that wolves were not the top dogs when they emerged on the landscape. And interestingly, this has proved to be advantageous to them, because growing up, emerging, evolving under such harsh, competitive environments forced the wolf to learn to behave in a very flexible manner. And as a species, they learned and evolved to be social and to be cooperative. And at the end of the Pleistocene, when all of these larger carnivores went extinct, this opened up a completely available niche for wolves to take over, and they thrived in that new environment. But it was having evolved under very rigorous oppression from larger dogs on the landscape that has allowed them to be so successful in dispersing across the landscape, learning to work together and to have those social tendencies that they have. A modern example of this is seen in the coyote, as we've eradicated most of the large carnivores that we're familiar with across North America. There's been what we call a mesopredator or mesocarnivore release. And the coyotes have just taken off in the last century. So this is important to understanding exactly how it is that the wolf was so successful and why it is the way that it is today. Taking a step back a little bit further, wolves belong to the order Carnivora, which shouldn't surprise anyone. They eat meat, they eat daisies, none of us would be here tonight. But they belong to the suborder of caniforms. So the family of carnivores, the order of carnivores, is divided into two branches. You've got your cats and your dogs. Again, big surprise there. Everyone knows the cats and dogs are different and that they don't get along. Some of the canines' closest relatives today include bears and seals and some of your weasel family members, your mustelids, as well as raccoons. And this divergent evolutionary path that canines took, where they split off from the feliforms, your cats and your civets and your saber-toothed cats, has made itself manifest in their morphology as well as in their behavior. So here you've got your dogs, and something that has, again, helped them morphologically be successful in the landscape is their teeth. So most of us who have cats or dogs are familiar with the sharp, saw-like molars or premolars that these animals have in the back of their mouths. Those are known as carnassials, but what's unique about the carnassial of the dog-like animals is that they have this additional talonid, which is a flat molar surface on their carnassial. And why is that advantageous? Is that it allows them to ingest and consume a wider variety of things. They're not obligate carnivores like cats. They don't depend upon meat, and they can only ingest meat. So when times get tough, dogs are able to scrounge around and eat just about anything. They're generalists in that sense. That's very helpful evolutionarily. Bears took it, of course, to a whole nother level. But in addition to their teeth, wolves, dogs, other progenitors to our modern-day canids evolved longer snouts, longer rostrums, which ultimately allowed for more space for olfactory sensors to fit in those noses. So they became very good at smelling things. And also, subsequently, a longer snout helps them to breathe longer and self-regulate their body temperature so that they can travel further without overheating with all that fur on them. This ability to smell far, to travel far, and to eat from a wider array of foods allowed the wolf and other canids to do very well as they emerged on the landscape. Now, the progenitor to the modern wolf actually emerged from the Americas. All of our canids ultimately emerged from the Americas and traveled across what we call Beringia, or the Bering Land Bridge, during the early and mid-Pleistocene, where these animals traveled into Eurasia and ultimately evolved and became what we would recognize today as Canis lupus. This species emerging debatably 300,000 to 800,000 years ago. And after emerging as Canis lupus in Eurasia, biotic interchange, wolves traveled back and forth, into the Americas again. So here you've got a species with a global distribution and range. It's got no barriers to stop it. For those of us who are aware of the term speciation, speciation is the step that begins the process of evolution because populations become genetically isolated. So if there's a barrier, like a canyon or an ocean, that is going to separate one population from another, just like in the Galapagos, go back to your high school biology and think about Darwin, the species on those islands are going to develop, they're going to diverge and develop new characteristics and new behaviors over time. But like humans, there's no topography on the planet, really, except for the ocean, that can stop a wolf from getting from point A to point B. And so, for that matter, Canis lupus, as one species, became what we call an holarctic species. They dominated the entire northern hemisphere. Just as a point of fact, today the closest living wild relative that the wolf has is the coyote. Coyotes are endemic. That means they're just from North America. So you don't find them over in Eurasia. My genetics professor would hate it if I shared this because it's not this simple, but there's about a 96% genetic overlap between wolves and coyotes. That's about the same as a human and an orangutan, so that puts it into perspective. So, dog confuses you for someone else at the zoo. I don't know why. Now, as humans emerged and spread themselves across Eurasia, specifically, again, they inevitably encountered this highly social, very conspicuous animal on the landscape. We'll talk a little bit more about their behavior later on as packs and as individuals, but wolves are conspicuous. I mean, they howl for Pete's sake, and their howls can be heard for miles and miles. They're relatively noticeable on the landscape, unlike your cougars or your mountain lions. So undoubtedly, people were noticing these large canids, and we coexisted with them. Coexistence is a loaded word, doesn't mean we're always friends with them. But we coexisted with them for thousands and thousands of years. We shared a landscape with them. And the domestication process of the wolf is such a fascinating subject that we could spend an hour just talking about that. And maybe one of these times I will talk about that, because it's cool, it's fascinating. And it can't be overstated just how dramatically the domestication of the wolf altered human history. The domestication of the wolf, and I'm not going to get into all the weeds right now, a lot of it is still being debated, but it took place at least 16,000 years ago, more likely as early as 30,000 years ago. And to put that into perspective, the next wave of domestication that took place with aurochs, which became cattle, and horses, and sheep, and pigs, that didn't take place until 9,000 or 8,000 years ago. So we had domesticated the wolf well before we domesticated anything else, including crops and plants. What I think is very fascinating and relevant to tonight's discussion is that many people argue that wolves actually partially domesticated themselves through what we call the commensal pathway to domestication. Meaning that wolves on the landscape probably first started to domesticate themselves by following around human hunter and gatherer camps and scavenging on their garbage, their gut piles. And over time, generations of wolves became more and more habituated to hanging around the outskirts of humans. And wolves prefer to scavenge over hunting. Go figure. I mean, I like to also go to McDonald's instead of go out in the forest and hunt. So wolves scavenging off of human refuse for generations just closed that divide until someone somewhere got the brave idea of, hey, let's grab a wolf pup. And the rest is history. Believe it or not, your pet chihuahua that you have at home is genetically identical to the gray wolves that we have out in the wilderness. That's the wonder of artificial selection and inbreeding. Go figure. This is also going back to artificial selection. Domestication and the modification of the physical features of our dogs today, that's all about, again, modification of the genes, not divergent of the genes. So there's not a split, it's not a changed species. And for that reason, many biologists refer to my dogs, I've got two of them, I picked up one this week, what a mistake. And we refer to it as Canis lupus familiaris, rather than a different species entirely. But again, this whole relationship of humans suddenly depending upon this alternate force of power and of strength, this endurance, this ability to hunt more efficiently, to travel further, to not carry our own gear, to protect ourselves from other animals as well as other peoples. It changed everything, and it opened up the world of innovative technologies, biotechnologies, which ultimately changed the course of human history. Pretty darn cool stuff. And this partly worked because, just like us, they have a similar family structure. So here's a map showing the global distribution of wolves, both past and present. Pretty remarkable. The dark gray shows their current range approximately. The mid-tone gray is their historical range. And if you look at this map, it is no wonder that people have big feelings about these creatures. It's no wonder that people love or hate these animals. And I find this fascinating because the vast majority of humans will never encounter a wolf in the wild. And yet, no matter who I talk to, they've got an opinion, one way or the other. They've got an opinion. And these opinions are reinforced time and time again by how we tell stories about ourselves in connection with the natural world. And so, of course, give us some time, give our species some time to try and figure out how we are expected to coexist with this large carnivore in the modern world, because these animals carry a lot of social baggage that we've placed upon them. To get more specifically into the individual biology of wolves, I'm going to step away from their evolutionary history and I'm going to talk about what they are, or what we call them. Canis lupus is the scientific binomial that we use to refer to this species. Again, because they have such a tremendous distribution with no disadvantage when it comes to crossing large areas on the landscape, it's all essentially, going back a slide, it's all essentially one species, Canis lupus. There's different ecotypes, so populations that have localized and adapted to their own environment over time, or subspecies, but those beautiful white Arctic wolves that my friend Ronan took pictures of up in Ellesmere Island, it's essentially the same species of wolf as we have here, which is the same species as Canis lupus bailey, which is down in Mexico. Caveat, we do have Canis rufus in North America, which is more closely related to the coyote. That is the red wolf, and it lives over in Carolina. It's highly endangered. There's less than 2 dozen left. Different animal, but also a canine. Commonly, these animals have a whole bunch of names, as you can imagine. It's just like anything else in the world. Different groups of people, different experiences, different names that they apply to their experiences. But they're most commonly called gray wolves, spelled with an A because of the English. Thanks, guys. But not all gray wolves are gray. About 50% here in Oregon are black, and you see that across the western portion of North America. Really cool story there. I'm not going to get into it. We also refer to them as timber wolves, and again, a whole bunch of other things. On average, their lifespan is just 2 to 5 years, which surprises a lot of people. They have the potential to live up to 12 years, like a big dog, but most of them don't make it because life is hard. Even without people, life is just hard. On average, the wolf is about 100 pounds, but there's a lot of seasonal variability based on that. So I catch wolves, that's part of my job. I radio collar them, measure them, take blood samples, etc. In the summertime, wolves are the leanest, and they're going to be about 20 pounds lighter than they are in the dead of winter. That's when they're going to be their biggest and their fattest. That's because their prey are suffering in the wintertime, and their prey are strong in the summertime. So it's an inverse of what you might expect. As far as the reproduction goes, through artificial selection, many of you are probably aware that your dog has the ability to reproduce or go into heat twice in a calendar year, typically. But originally, it was just once, and that's the case with wolves. So they go through their estrus cycle at this latitude here in Oregon in the middle of February, around Valentine's Day. And they whelp or give birth around tax day, so 2 months later. Pretty easy to remember, but just one reproductive event in a year. And wolves reach sexual maturity generally around 22 months. So just shy of 2 years, that's just in time for their first breeding season, their first breeding opportunity. Although there is variability with this. Sometimes they don't actually, especially the females, they won't reach sexual maturity until they're 3 or 4 years old. And a wolf reaches its peak fitness at around 3 to 4 years of age. After that, it's downhill. Now, that's a lot of information about the individual, but like I said, while that might be interesting, tonight we're talking more about what I'm fascinated with, which is their social behavior and their cooperative behavior. As I mentioned, wolves are a short-lived, fast-paced animal, which is an anomaly when we look at large carnivores globally. I mentioned I worked with grizzly bears before. Grizzly bears are arguably the slowest reproducing terrestrial animal that we have in North America. The females don't reach sexual maturity until they're 5 or 6. Then when they reproduce, they keep maybe one cub for 3 years. They might have 2 cubs, but usually 50% mortality. And then it's another year before they're going to reproduce again, and they ultimately can live up to 30 years in the wild approximately. Very different from a wolf. A wolf is fast-paced, lives hot, dies hot. And fortunately, for its own advantage, it lives in what we call a cooperative breeding unit, or a family that involves a breeding pair, a male and a female, a mom and a dad, which give birth to offspring year after year, and the pups born in previous years stick around and help with raising the current year's offspring until they're ready to go to college and find a boyfriend or girlfriend out there. So you generally have a multi-generational unit that's cooperating and working together to support one another on the landscape. Wolves are monogamous in most cases. Biologically, evolutionarily, it makes sense for a couple of reasons I'll just touch on in a couple of slides. But one of those reasons is their estrus window is like a week or less, really small window. If the male is not in the right place at the right time, he's going to lose his reproductive window for another year. And most importantly, and I'll get to this in a slide or two, the male has the unique ability to help raise offspring, which is not the case, or at least not practiced, in most other mammalian species. So this cooperative breeding unit is what we call a simple wolf pack, or a simplistic situation. It's a nuclear family familiar to most of us, but like many of us are aware, human families are not always so simple. We get grandma living with us, we have a stepdad, we have an adopted sister. Families can be very complex, and that's the same with wolves. And in areas where we've studied wolves, like extensively in their social grouping, like in Yellowstone, we see that as packs establish themselves longer, the packs become more complex, meaning it's less mom and dad and maybe 1 or 2 generations of offspring, but it very often will keep grandma or grandpa around for a longer period of time. They're more likely to have adoptees come into the pack. And in some cases, they work as a communal breeding unit. So you might have a couple of breeding females and even a couple of breeding males. That's usually not tenable for long. And we don't see this in places where humans and wolves overlap, because that's generally where we have higher wolf mortality rates. But wolf packs, with their family groups, they can vary in size. I would call the basic of a pack is a breeding pair. So 2 wolves, and the largest confirmed wolf pack ever documented was in Yellowstone, the Druid Peak pack, which for a very hot minute reached about 36, 37 individuals. That was, again, a bizarre circumstance because you had 3 groups come together, and then they all had their own breeding females, and it all fell to pieces shortly thereafter. It's just too much chaos and too many resources to compete for. Competition again, the big downside to living in a social group. But this is an important feature of their biology that I'm going to hammer over and over again. Wolves are very effective as predators, as scavengers, as being tenacious and solitary on the landscape. Little knucklehead, huh? Wolves exhibit what we call fission-fusion behavior, meaning that more often than not, they depend upon the group, but if necessary, they can survive on their own. the reason why packs form, and I'll make the case for this in the time remaining to me, the reason why packs form and why they last as long as they do is because it works optimally for reproductive success. Time and time again, we've seen that pup survival is influenced by pack size. The more helpers you have, the more committed you are to resource maintenance and gathering up until a point. Interestingly, some studies have shown that wolf packs with individuals beyond the litter of pups, beyond 8 individuals in the pack, show a decrease in pup survival. And again, it's because of that fine line you're towing between competition for resources and resource gathering and security. On average, a wolf pack has a litter of 6 pups that are born to it. And again, because life is tough, there's a lot of variability with neonate or newborn survivorship. Usually you only see about 2 or 3 of those individuals that make it to the end of their first calendar year. And that's the same with deer and elk and everything else, about at least 50% mortality. But it all, again, depends on how complex your pack size is. Interestingly, here in Oregon, our average pack size is between 5 and 6 individuals. That's generally what we see here in the state of Oregon. Another great photograph by Ronan, but bouncing back to what I mentioned earlier about the father's rather unique role in raising offspring, most mammals, I mean, we should all be aware of this, that most mammals, especially the males in those groups, do not stick together monogamously after copulation. So the father comes along, he fertilizes the female, and then he leaves because, well, he can't make milk. So why stick around and help the little pup or the little cub reach maturity when it has a higher rate of reproductive success, biological fitness success, going around and fertilizing as many females as possible. But with wolves, the male actually does participate in raising its young. And it does this in a very crucial way. When the female, or the bitch, when she reproduces, when she whelps in a den, she stays with the pups and she has to nurse the pups for a week to 2 weeks. And during this time, she depends upon the male to go out and hunt and bring dinner back for her. When you're lactating, it's more calorically exhaustive to lactate and produce milk than it is at any other time during the entire phase of pregnancy and gestation. And so she really depends upon the male being able to bring home dinner. And again, if you have more helpers bringing dinner back to the female, the odds of your pups not starving or her drying up are going to be a lot higher. So not only does he help bring back dinner for her, but as the pups grow and as they're weaned off of mother's milk, the male, and if you again have auxiliary members, other members of the pack, they're able to go and hunt, masticate the food, digest it partially, come back and regurgitate it to the pups. So not only is the female capable of producing milk, but the male specifically is capable of providing food for her as well as for the pups. And this ensures his Darwinian fitness. He's able to make sure that his pups have the best chance of survival by persisting with the female and ensuring the success and growth of his pups, which is pretty darn cool, if you ask me. I'm getting close to the end of my time. I've, of course, got more slides to share with you, because that's just how it goes when you prepare these things. But we'll talk for a minute about scavenging and hunting. One of the misnomers or myths regarding wolves, and it's persisted for a long time, is a wolf pack is a gang or a mob of individuals that are insatiable. The more wolves you have, the more food they can gobble up. But time and time again, we see again a give and take between pack security, reproductive success, and pack size. And there have been some phenomenal research studies conducted on wolf hunting behavior. McNulty et al. In 2012 and in 2014 and isn't this cool? These wolves are the Warm Springs pack. I work with the Confederated tribes up there, and they do all of their wolf trapping and collaring. These wolves are scavenging on a wild horse that died of natural causes. So it's a big animal, and they were happy to dink around on it for multiple days until the bears showed up. But when running models considering wolf predation of elk, which is the favorite food of wolves, for reasons I don't have the time to get into, time and time again we saw that the capture and kill success rate peaked with 4 individuals. If you had more than 4 wolves participating in a hunt, if your pack was larger, you had more and more loafers or free riders that were hoping to get a meal and were maybe running at a half-assed pace aside. Typically the male and female breeders who are more committed to taking care of the pups. And this, again, reached a point where having more members of the pack participating in a hunt actually diminished resources when they're consuming the kill that they've made, and there's not enough pie to feed everyone at the dinner table. And it's about that time when those older siblings say, this house just isn't big enough for me anymore. It's time to go off. I'm hungry all the time. Mom and dad are allocating most of the resources towards the pups. It's just not worth it for me to stick around. We see this often in the summertime when times are lean for wolves. Packs are very much less cohesive in the summertime. And you have individuals going around looking for ground squirrels and rabbits and anything that they can eat while mom and dad are bringing back the lion's share of the food for the pups. So this is, again, a unique dynamic where success with hunting peaks around 4 wolves. And again, because wolves hunting their prey is so challenging, they're not an ambush predator, they're what we call a cursorial predator, which means they have to chase their prey down. It's exhaustive, they're going after animals much larger than themselves. It's a risky business. Wolves very often will prefer to scavenge whenever possible. Going back again to their original domestication. They're not dumb, they know that an easy meal is not something to pass up. So as wolves reach an opportunity where they're sexually mature, it's just not beneficial for them to stick around with mom and dad anymore. That's when it's time to disperse. And you have what are known as lone wolves. These are not actually permanently lone wolves in most cases. They have a goal, and their goal is to go out and to find a mate and to start a family of their own. It's their biological drive. Now, very often we hear people talk about alpha wolves, alpha males, alpha females. You don't hear that in the science community. We do not refer to any wolf as an alpha. It's not an alpha male and an alpha female in a litter of pups. Thank you, Rick McIntyre. He's a friend of mine with this more recently published alpha female book. He knows this as well. But alphas are not the terms that we use because alpha describes a personality. That term first came into being when people were just starting to study wolves in zoos and in captivity, where there is a very rigorously established hierarchy of behavior between the wolves in a captive setting. But out in the wild, it's all personality based. Sometimes the female is more proactive at getting things done. Sometimes the male is. It's all wishy-washy depending on who's going to be taking the lead in determining what that pack does for that day. So with this in mind, when a wolf disperses, it can be a male or a female, and both of them have the ambition to ultimately sire their own or mother their own litter of pups. Unfortunately, or just how the way things are, again with social behavior comes competition, and competition ultimately leads to warfare, essentially. We're very familiar with this, and that is unfortunate. But wolves also experience this highly violent and combative relationship with their own species. In places where humans are not the natural cause of mortality and wolf packs are large, wolf density is high, the number one cause of natural mortality is what we call intraspecific conflict, so wolves killing wolves. Wolves, unlike many animals on the landscape that we say are territorial, wolves actually are territorial. They establish their territory as a group to defend the resources that they have for their family, and they will kill other wolves to defend those resources. And so a dispersing wolf coming into a new territory could very easily be killed. Stiff competition for breeding rights, let alone for food resources. You don't want to have 2 litters of pups generally in an area where there's not enough resources to support 1 litter of pup. And so again, time and time again, we see this conflict between wolves as they fight with one another. And in some ways, this has led to a very delicious, nerdy, ongoing debate about wolf population limiting factors. A debate which I'm excited to participate in with some of the research we're conducting here in Oregon. Wolves, as a population, of course, are limited by the prey that is available to them. So as we look at wolf recovery, we have to consider what biomass is available on the landscape to support them, but we also have to look at their own intrinsic behavior as they hash it out with one another, and not just violently, but also as they compete with one another for breeding opportunities, for resources, for space. Ultimately, these can be factors which limit the population, which ultimately can influence management of these animals. In a nutshell, these animals work together, they live together in these family units, and the reason why they do it is to raise their offspring. Wolves are successful hunters in small groups, even as individuals. It certainly helps to forage as a group. You can cover more ground, you can cooperate to bring down big prey, but the reason why they live in packs is in many ways the reason why we live in family groups. It's to see the successful rearing of their offspring from start to finish. I'm going to conclude really quickly by talking just briefly about the current status of wolves here in Oregon. And I don't have enough time to get into the weeds, and this is not a meeting about wolf management, but it does tie in with the biology, so I'll be quick. Many of us are aware that as Euro-Americans, like my family, came westward, there were good animals and there were problematic animals. And the problematic animals were the ones that competed with our own economic securities, and that was primarily livestock husbandry. And so this led to the eradication of large carnivores across North America. And this also is not a North American story. This is a story that has taken place for thousands of years where humans and large carnivores come into conflict with one another. As early as 1843, wolf bounties were established in the state of Oregon. 400 wolves were removed between 1913 and 1946. And the last wolf that was turned in for our ongoing bounty was submitted in 1947, ultimately indicating that we had lost a biologically viable population. Even if we had an individual or two that came in through the state or lived in the state, the population is no longer genetically and biologically viable. Since this time, of course, we've changed, the landscape has changed, and our footprint has altered the landscape in many, many different ways. And so I'm regretting that I have these slides to go over in the next couple of minutes because it's a long discussion which I don't want to do an injustice to. But wolves were ultimately reintroduced into the northern Rocky Mountain states, preceded actually by natural recolonization of wolves in northwestern Montana in the 1980s. A lot of folks don't know that. Wolves started to come down from the nearest existing population in Canada down into Montana in the 1980s. And then in the mid-1990s, wolves were reintroduced into Yellowstone National Park as well as central Idaho. And from these populations, there has been recovery and expansion, and wolves have spilled into neighboring states, such as Oregon. So this is a now antiquated map by a whole year. It's also a loud and noisy map that gives me a headache, and so I apologize for it. But there's Oregon's wolf population has been recovering naturally since the late 1990s. We had our first collared wolf from Idaho that was reintroduced come all the way over into the state of Oregon in 1999. We had our first breeding pair in 2008. And since then, wolves have advanced slowly across the Oregonian landscape. But as they do this, again, this is not a management meeting, this is a biological meeting. People like myself look at the landscape and how it has changed. And some people are frustrated, some people are excited that wolves are back. Setting that aside, I'm interested in understanding what recovery is actually going to look like, because we don't have the prey that were here before. There's been a lot of urbanization, there's been a lot of changes to the landscape. The way we use the landscape and have a relationship with the landscape is certainly different. So this is ultimately going to impact wolf recovery, and trying to predict and foreshadow what, again, recovery actually means and how we're going to define it is an interesting puzzle that many of us are trying to figure out. Wolves are apex predators. They are native to Oregon. They are native to North America. They were here for a long time, well before humans got here. Despite their ability to fulfill an ecological niche as apex predators, it's important to realize time and time again that humans are the top dog on the landscape today. And whether we're hunting them or just recreating or we're developing habitat, we are ultimately diluting the trophic cascades and ecological complexities that these animals are associated with and a part of. In conclusion, wolves are a fascinating species. People have big feelings about them. But I think when I look at the wolf, what is most remarkable is not its ability to persist. It's not the individual strength or tenacity or its stamina that the individual organism has. Rather, it's the ability that this animal has to succeed when challenges arise. And it's because they live in cooperative groups that they're able to do this. Even when the whole world seems against them, they have persisted on the landscape. They have recovered in areas where they were extinct not that long ago. And that's truly remarkable. And I think that there's a sense of danger if we have the arrogance to not look at other species and consider how they are succeeding by cooperating, and we could potentially do the same and are doing the same in many ways. Again, a remarkable species. Thank you all for coming out tonight. Sorry it was rushed.
So, Aaron can take a few questions. Just raise your hand.
Whoa, you mean I have to call him, or are you going to call him?
You want me to call him?
You do it.
Bob?
You probably noticed, perhaps you haven't, that Sisters has developed a whole new niche for deer that seem to thrive. They're in our neighborhood, they walk across the street, and they are sort of oblivious to us. Is there a potential that wolves would follow those deer into these communities, not just Sisters, but other communities? Or are they more or less afraid of humans and trying to steer clear, even though there might be available prey where we are?
Good question. I hope everyone heard that. In a nutshell, it boils down to how likely are wolves to become habituated to semi-urban or suburban areas where deer or even elk in some cases might come. I can speak generally, but wolves are animals, and all you can do is generalize. The likelihood of there being an established pack within a stone's throw from an urban center is very unlikely. Wolves, unlike coyotes, are much more neophobic and anthropophobic of people. So it's unlikely. However, yes, you can see wolves come into areas that sometimes surprise you. I mean, the fact that we have wolves from Oregon, which have dispersed all the way down into Southern California and have established a pack. I mean, if there's anything that I have learned from studying wolves over the years and having compared them to every other species that I've worked with, nothing moves like a wolf does. They cover more ground in a shorter period of time than any other animal that I can conceive of in North America. And so, is it possible, and has it happened, where someone comes out their front door in a semi-rural, suburban area and seen a wolf? Yeah, it has. Is that an anomaly? Yeah, it certainly is. So never say never, but yeah, it's possible. Mortality rates, just setting aside attitudes, the mortality rate of wolves getting hit by vehicles is really high, and it increases as wolves, in Oregon specifically, move into areas with higher human density. So I don't foresee that as a concern. Yes, it's possible though, absolutely.
You used the term trophic cascade at one point, which I, from a layperson's standpoint, I vaguely associate with the idea of the effects of reintroducing wolves on bull ecology. And I read recently that some of the basic ideas that we've operated under since the introduction of the wolves to Yellowstone in particular about those effects, that those have been challenged by some more recent studies. And I wondered what you thought about those effects and about that debate.
Absolutely. So I am heavily involved in that debate with my time in Yellowstone, and my doctoral professor is the one who's challenged those notions. And so this slide here is kind of my oversimplified summary of it. Most of us are aware. If you're not, I'll let you know now that when wolves were reintroduced into Yellowstone, we saw a resurgence of vegetative growth along riparian areas because the elk population, which was at that time unnaturally high, we're talking 21, 22,000 elk in one herd, so in one concentrated area. Those elk had been overgrazing and overbrowsing on the vegetation. Wolves were reintroduced, and the elk population became manageable, and suddenly, of course, you have a resurgence of vegetation. That's the cute, simplistic story, and it's often told that that is a perfect vignette of trophic cascades and how they work. But, like anything else in the real world, it's way more complicated than that. That story completely omits the fact that in order to bring the elk herd down, Montana initiated a late season elk hunt in addition to their general season elk hunt. That late season elk hunt was targeting cow elk, because those are your baby makers, that's how you impact a population. And they were harvesting as many as 7,000 elk during their season. Well, the wolves that were brought onto the landscape in Yellowstone, you're talking about a population of sub 100. Grizzly bears have been eradicated from Yellowstone, just about. Mountain lions have been eradicated from Yellowstone. But we saw a resurgence of mountain lions coming back onto the environment in the same decade that wolves were reintroduced. Grizzly bears, which consume 60% of our marked neonates, that's our brand new fawns and calves, they quadrupled in number in the same time frame as this study period. We also had drought, climate change effects. All of this is to say that yes, wolves are an essential component to the trophic cascade, but are they the component? Are they the reason why elk populations fluctuate? No, it's a wide matrix, a huge variety of things that have influenced that whole system shift. And again, that's why I stuck this slide up here, because wolves aren't the top dog. They're a part of the equation, but nothing alters elk herd behavior like a four-wheeler driving straight through the herd, right? Nothing does it like a late season elk hunt, which is additive predation by humans on the population. And that's not to say that humans are bad, we're just a part of the equation too. So.
What's known about when one of the breeding pair in a pack loses its life? What's known about the result to the pack?
Good question. So what happens when a specific individual, more specifically a breeding individual, dies in a pack? One of my dissertation chapters was on this. Not all wolves in a pack are created equal. Some have more value than others in terms of pack cohesion and reproductive success. It's very similar to a human family, right? What happens when one of the parents dies? A lot of options suddenly present themselves. With wolf breeder loss, wolf breeder mortality, the odds of reproductive success decrease a lot. And pack persistence decreases a lot, meaning persistence of the pack into the next breeding season. If you, conversely, were to remove a pup, that's what we call compensatory mortality. And I know that that sounds very unsavory. No one wants pups to die. But the fact is that there's a lot of pups, and pups do die. And if you lose pups, the breeders will stick around, and the pack will persist, and they'll have another go at reproduction the following year. But if an individual breeder is lost, a lot of different things can happen. In an area where there's low wolf density, the pack is most likely going to break up and disappear. It will dissolve, is what we call it. In higher wolf density, perhaps you have another individual from a different pack that suddenly becomes successful, dispersing and becoming accepted and adopted into that pack. Wolves, like many animals, avoid inbreeding at all costs. We've got major histocompatibility complex and other things that we're unaware of, but consciously avoiding incest thanks to. Those are at play with wolves. And so, yeah, it's not all wolves are created equal. The breeders hold the pack together.
Can it change their hunting behavior as a pack?
It can. It can more often, in my experience, and this is not something I've quantitatively examined, but yes, it can shape their territorial and range patterns. And that also can be applied, though, to other pack members dying and the cause of death, for example. So when there's conflicts where there's chronic, we call it chronic depredation, wolves become habituated to preying upon livestock, and it becomes a problem to the point that wolves have to be removed from that area in order to stop the chaos from accelerating. The goal, again, is to remove, beginning with just an individual so that they will get the picture that something bad is up. They need to shift away from that area, change their behavior.
Got time for a couple more back there?
So, prior to European settlement on this continent, what was the relationship of the native indigenous population with the wolf?
Good question. So what was the relationship of the many peoples who inhabited North America prior to Euro-American colonization of the continent? In a nutshell, people are complex all over the world, and livestock husbandry and the advent of agriculture changed a lot of people's mental attitudes and towards their relationship with the natural world. That said, I cannot speak on behalf of every indigenous group native to North America. But I will say that we know from oral traditions and from the people that we engage with, that I work with, that those attitudes are complex. Generally speaking, the wolf was often seen as a brother or revered, but that's not to say that there weren't groups of people that also saw the wolf as problematic, and a food come first attitude was developed by that particular group of people. We've seen that in parts of the Pacific Northwest, actually, where a focus is generated to give more attention to the deer and the elk and the things that the people depend on than the carnivores, and in some cases those carnivores were locally eradicated at a smaller level. So people are complex all over the place, although generally speaking, yeah, it's less of a problem when you're not depending your entire survival and economy upon domestic livestock.
Is it true that wolves will mate with coyotes in order to breed or
Good question. So, wolf-coyote hybridization, is that real? Is that a thing? In the American West, it is not a thing. So we take hundreds and hundreds of biological samples, genetic samples from wolves. Every wolf we touch, every wolf we capture, and wolves hate coyotes. Wolves hate coyotes. In fact, when wolves were reintroduced into Yellowstone, we saw the coyote population decrease by 60%. Wolves don't cannibalize on coyotes, but they see them as a competitor. It went from being cool to study coyotes in Yellowstone to not being cool to study coyotes in Yellowstone. However, I think PBS, I like PBS, but they kind of made a headache for me. They did a special on what they called coy wolves a few years ago. In areas of eastern North America, where the wolf population has crashed several times in millennia, but most recently during the late 1800s and early 1900s, coyotes and wolves have hybridized. You get a horny wolf and a horny coyote, and they're going to make babies. That doesn't happen where wolf density is high enough that there's no desire or interest in that. In fact, there was a study conducted by one of my other advisors in a captive wolf-coyote interaction. The female wolf was bred with a male coyote, inseminated, I should say, and she killed all of her pups at birth. So it's not something that we see happening. But in parts of eastern North America, you have some coyote in those wolves. Around the Great Lakes states, it's estimated that in some cases 10 to even 20% of those wolves have some form of coyote DNA in them.
Okay, one last question over there.
Do you know the age of the wolves in the Millennia Basin, and were they part of the Warm Springs pack? Were those wolves coming down from Warm Springs?
Good question, very good question. So a question about local wolves, we have the Metolius pack, which is close to sisters. Speaking of wolves and their interaction with suburban areas. The Metolius wolves, we have not captured and handled. I trap wolves, I trap them to radio collar them, so I live trap them, and I'm really good at it. It's a job skills that I have developed over my entire life. They're a difficult pack to try and get a collar on because there's so much private land out here that I don't have access to. And so I have not handled them and subsequently taken their DNA. However, we have collected their scat, and we can run genetic tests to see what and who they're related to, and that is happening right now. So within the next year, we should know. My guess is that they're more closely related to the White River pack, which is north of the Warm Springs pack, and probably the Warm Springs pack too. But the White River pack has been here a lot longer. They're all gray. The Metolius are all gray. The Warm Springs has black wolves in it, and due to the black gene being the dominant gene, you can't have two gray wolves make a black pup, so you have to have some other individual in the population. Their age, though, this is again an estimate. They definitely reproduced this year for the first time. There's a rumor that maybe they had a pup last year, but they definitely didn't have pups by the end of the year. I would guess that based off of that, they've been in the area for 3 years. She's probably 3 or 4 years old, because she's now just getting the hang of it. She's now finally figuring out how to be a mom and raise pups. And he's probably similar, but maybe a year older. He's a lot larger than she is. She's a petite little female. So
Thank you.
you're welcome.
Okay, one more, that's it.
No, you're fine. We got nowhere to be.
So wolf pack is very social animals. Have you ever studied epigenetics of the wolf?
Yeah, very, very good question. So epigenetics and how their environment
Environment affects it.
can influence their behavior, their genetics, and who ultimately they become. The best roundabout answer I can give you is wolves behave like wolves where their environment is consistent with other wolf populations. And here in Oregon, we have a history of wolves depending upon elk for food. And the reason why we have wolves in the Yellowstone area, in central Idaho, in Montana, in British Columbia, in Alberta, why all of this is one continuous genetic flow, one continuous population, is because they all exhibit the same kind of environmental behavior. They've been exposed to the same environments, which has not at all altered their genetics. Now, there is an interesting study looking at coastal wolves, which sort of, kind of, comes down into Oregon. Historically, at least it may have. Coastal wolves along British Columbia, Vancouver, into Washington, and again, probably parts of coastal Oregon. That is a population that for many, many generations scavenges upon salmon and washed up whale carcasses and seal carcasses, and they have a culture, undoubtedly, that is different, and a dependency upon food which is different than wolves in the state's interior. So they would be considered based off of epigenetics and ecotype. Yeah, good question.